Hi all, this is Asha, Assistant Professor of Computer Science and Engineering from Emmanuel Arasa JJ College of Engineering. Now we are going to learn a short topic about finite automata. So what is finite automata? Finite automata are abstract machines used to recognize patterns in input sequences, forming the basics of understanding regular languages in computer science. Also, the finite automata consist of states, transitions, and input symbols, processing each symbol step by step. If ends in an accepting state after processing the input, then the input is accepted, otherwise it will rejected. And finite automata widely used in text processing, compilers, and network protocols. And the next one is features of finite automata. Some of the features of finite automatas are input, output, states of automata, state relation, output relations. And the next one is components of finite automata. Some of the components of finite automata are include as a set of states, a set of input symbols, a transition function, a start state, and a set of accept state. And the next one is formal definition of finite automata. A finite automata can be defined as a tuple, that is A equal to set of letter Q, summation, and the small letter q and f, and also sigma, where Q is a finite set of states, summation set of input symbols, and Q is the initial state, F is the set of final state, and sigma is the transition function. And next is the type of finite automata. There are two types of finite automata. First one is deterministic finite automata, that is DFA, and the second one is non-deterministic finite automata, that is NFA. So what is deterministic finite automata? It is generated as set of Q epsilon summation Q F and epsilon, that is tuple. In DFA, for each input symbol, the machine transitions to one and only one state. So this deterministic finite automata does not allow any null transitions, meaning every state must have a transition defined for every input symbol. And the second one is non-deterministic finite automata. So the non-deterministic finite automata is similar to deterministic finite automata, but it includes the following features. It can transition to multiple state for a same input, and also it allows null moves, that is empty moves, where the machine can change states without consuming any input. So the next one is comparison of DFA and NFA. Both non-deterministic finite automata and deterministic finite automata have the same power, and each NFA, that is non-deterministic finite automata, can be translated into a deterministic finite automata. So there can be multiple final state in both the DFA and NFA, and the non-deterministic finite automata is more of a theoretical concept, and also deterministic finite automata is used in lexical analysis in compiler. So hope you well understand about this topic. Thank you. Have a nice day.